Hello guys, I am Sam. This video is about the work energy theorem, which will discuss the equivalence of work energy transfer and also the law of conservation of energy. But before that, it is required to understand what is work, what is energy, and the relationship between work and energy. Firstly, energy. I remember that the first time when I heard the word energy, this came to my mind. In fact, energy is the most thing everywhere. Chemical energy from the gasoline powers Lamborghini, Maserati, Bentley, and Ferrari. You don't have the money. Another example will be the electrical energy, which keeps our computers going so that we can play in video games. An important fact that needs to know is the conservation of the energy. That energy is not created or destroyed, but is only transformed from one form into another. Illustrating a graph, it shows the total energy of a system may change as a result of interaction with its surroundings. Second part, work.
Sam, you are 18. Go find a job and do some work.
That's child labor. So the definition, the work done by a force, is the product of the force in the direction of the displacement times the distance traveled, as shown as the equation and the graph, where F cosine theta is the components of the force in the direction of the displacement, S is the displacement. Here is an example. Assume I give a 20 Newton force horizontally from the left towards to the right on the skateboard and it moves 1 meter. Based on the equation, 20 newtons times 1 meter times cosine 0 degree. Second example, Chinese New Year is approaching. I think I should go to the gym to keep fit. This boy ain't do no work. What? Displacement is 0. You lift up and down, it backs to the origin. How come you do any work? About this? Still not. You work in horizontal direction, but the force is in the vertical direction. So they are perpendicular, which means cosine 90 degrees, which is 0. Good point, I quit. This is pointless. Third part, we have kinetic energy, elastic potential energy, gravitational potential energy. We will be mainly focusing on the equivalence of work energy transfer and the law of conservation of energy at this part. So you can pause to look at the formula and the derivation process at the table. So to understand work and energy transfer, we must understand work energy theorem. It means the net work done by all forces acting on a body is equal to the change in the kinetic energy of the body. We can use the equation of this to represent that. Here is an example. Assuming this medium is 0.1 kilogram with the initial speed of 1 meter per second, and moves horizontally at point B, its speed becomes 2 meters per second. Then its initial kinetic energy is 1 over 2 times 0.1 times 1 equals 0.05 joules. And its final kinetic energy is, using the final kinetic energy to minus the initial kinetic energy, to see that the work done has gone into the change in the kinetic energy of the medium, and to think as the work done as energy transferred by increasing its kinetic energy. So what about the law of conservation of energy? Remember that I said this previously? Energy cannot be destroyed or created. It can only be converted from one form to another. From the textbook, it says when Q plus W equals 0, the system is called isolated, and in that case, delta E equals 0. The total energy of the system does not change. We have conservation of the total energy of the system. As we learned so far, the total energy E consists of kinetic energy, elastic potential energy, gravitational potential energy. It consists more such as electrical potential energy. Using the equation to represent this is also called the total mechanical energy. So here is a flawed demonstration based on the idea of the law of conservation of energy. Assuming a ball falls from the air at the height of 2 meters with the initial velocity of 0 and bounce back to its highest point, h2, with the velocity of 0 again after it hits the ground. The first stage demonstrates how does the gravitational potential energy transfer to the kinetic energy, and the second stage demonstrates how does the kinetic energy transfer to the gravitational potential energy. According to the law of conservation of energy, the ball before dropping should contain the same energy as the ball after hit the ground and bounce back, which indicates mgh1 equals mgh2, and A indicates that the ball should bounce back at the same height as the height where it drops the ball. But according to my experiment, it is apparently not, because the law of conservation of energy is inapplicable in such environments for doing this experiment. There is air resistance, there is not perfect elastic collision to make sure there is no loss of kinetic energy, and there is friction between the ball with the ground as the ball rotates and so on. Therefore, the law of the conservation of energy in such experiments do not stand. However, this demonstration shows us how does the gravitational potential energy transfer to the kinetic energy, and how to justify the environment of doing experiments of the law of conservation of energy. So this is all. Today I introduced what is work, what is energy, and the equivalence of work and energy transfer, and the law of conservation of energy. You can see the connection between these concepts and how do these concepts apply in our real life situation or like doing experiments. So thanks for watching my video. See you.